see types of different models used in geometric modeling, and this is related to chapter number 2, computer graphics and geometric modeling. So what are these model and what is their use, especially that we will see. So basically there are three types of models. First one, wireframe modeling, then surface modeling, and then solid modeling. These three are the basic types of models, and these are important for selection of drawings, selection of models when you go to the software and you start modeling the drawing. Obviously these are having different applications. For example, if you want to draw the model of car body, there is a different type of model. If you want to draw a model of skeleton, there is a different type of model you have to select. So as per the applications of model, representation of model, we have to select the type of model accurately. Now first of all, let us see what is this wireframe model. Wireframe model, I will simply define it as it is generated with the help of points and curves. There is no surface in the wireframe model, there is no solid in the wireframe model. Simply it is constructed with different points and the curves. So these points and curves prepares the model. You can simply call it as it represents the skeleton of the object. It represents a skeleton of the object, that is simply called as a wireframe model. Now what is its advantage that we will see? Obviously it is a simple method and it requires less memory space, as it is generated with the help of points and curves. Obviously it will have less memory required in this modeling. That is so simple. Now if you go to the its forms, it forms the basis for surface and solid modeling. That is also true. Why? Because when you extrude one line, it becomes a surface. I am repeating, you draw one line, you extrude that line, it will become a surface. So wireframe model, it was required for generating the different surfaces, and from the surface you can generate the solid, that is so on. But it is required for generating these two types of model, surface model and solid modeling. Then manipulation in the model can be done easily and quickly. Obviously it is, see, actually wireframe models are not that much critical. If you make wireframe model very critical, so it is very difficult to understand. Because of the difficulty in the structure, you cannot interpret a wireframe model. So wireframe model must be very simple to understand. So therefore, if it is simple, you can do the different types of changes in that wireframe model. Now let us see one diagram which represents the disadvantage of this wireframe model. So this is the one of the serious limitations in wireframe modeling. You can see this diagram on the screen. One of the serious limitation, that is orientation and weaving plane. Due to this, it is very difficult to interpret the object from particular weaving plane and creates confusion. See, if you see the object from this side, it will look different. If you see from this side, it will look different. If you see from this side, it will look different. It is okay because it is a view from different side. But you cannot exactly interpret what is the orientation of this object. This is the problem. अभी आपके सामने जो बॉक्स है उसके अंदर एक बॉक्स है, फिर उसमें लाइंस जो है वो ज्वाइन किए हैं. तो यहाँ पर ऑब्जेक्ट का एग्जैक्टली स्ट्रक्चर क्या है जो उसमें दूसरा एक बॉक्स है, बॉक्स के अंदर एक दूसरा एक बॉक्स है, उसका एग्जैक्टली स्ट्रक्चर क्या है, ये आपको समझने में थोड़ी सी परेशानी होती है. सो दिस इज अ लिमिटेशन ऑफ wireframe modeling. You cannot exactly interpret the inner object in the wireframe modeling. This is the problem. Now we will go to the next point, that is another advantage, lack of limitation to determine object profiles such as a circle or curved surface. If you see this point, you see this diagram, it shows a curve here. Here curve is there, and there may be confusion whether it is a simple curve or it is a circle, it is having a specific radius, it is having a center or not. You cannot easily determine what will be the center of this curve. So it is quite difficult in wireframe modeling. If there is a curve, there must be a center. This is a simple logic and straightforward. But it is difficult to identify the center of this curve. So this is one disadvantage of wireframe modeling. Now another disadvantage is that physical properties such as a mass, surface area, volume, center of gravity, etc. are not possible to calculate. Then wireframe model has no knowledge of surface faces, therefore it will not detect interface between two mating components. This is also disadvantage, because if there is one object here and there is another object, so the common surface in between these two objects you cannot determine. This is the one disadvantage. Common surface in between two objects, it is very difficult to interpret. This is disadvantage. Obviously you can understand easily if there are two boxes and these are joined together, so common surface belongs to which box, it is difficult to understand in wireframe modeling. This is a serious drawback. So therefore it is not implemented in NC tool manufacturing, then in robot arm simulation. Say all types of, these are types of solid models and it comes under solid model, robot arm simulation. Then to construct the model we require lot of data compared to solid models. I have experienced this a lot, because in initial days when I was using ANSYS software, and ANSYS software just new versions was launched, their solid models were very difficult to draw in ANSYS software. So we used to enter the coordinates of the point, then join that 2 point. Likewise we used to waste lot of time for drawing a simple models made up of points and lines. Nowadays it is simple to draw a model in CATIA, but in initial cases it was very difficult to import the model from ANSYS software from CATIA software to ANSYS software. But we used to draw models by the data of point, the data of line. So one by one structure we used to draw, and it was very time consuming. It was very time consuming. So therefore and it requires lot of data. So wireframe model is not suitable nowadays for constructing critical or huge size models. Then it do not represent an actual solid, no surface and no volume. You cannot use the wireframe model obviously for modeling of a mobile, modeling of a laptop, mobile of a car body, because it does not represent a solid itself. It is just representing a skeleton, and it cannot be used for modeling a complex and curved surfaces. Wireframe modeling, obviously it cannot be used for modeling curved surfaces. and which are very complex. Simple curves you can implement in wireframe modeling to draw the models. So complex shaped curves, these are difficult to draw. Then next type of the modeling, that is the surface modeling. We will see in the short now. Surface model, it represents just a surface, it does not represent a solid. Please keep this in mind. One simple example I will tell you. There is one box and there is nothing inside the box. So box has different surfaces. You cannot call it as a solid. Obviously their surface has some desired less thickness. Obviously their surfaces have a desired less thickness value, but it does not represent a solid inside that box. Just example I am telling you. So whenever you extrude single line, it becomes a surface. Whenever you extrude a single line, it becomes a surface. So surface model, in short, you just remember one sentence. Surface models are just used for representing appearance and aesthetic of the object. In short, you can call it as it is just used for representing appearance of the model, how it looks. Rather, I will say it cannot be used for any kind of finite element analysis. It is just used for representing the appearance. Again and again I have repeated the same sentence. Please understand this. Now, advantage of surface model, it eliminates much difficulty and non-uniqueness which present in wireframe models, such as a hiding line. That lacuna is removed from wire modeling, and it is improved in surface modeling. It renders the models for better visualization and presentation. Objects appear more realistic. If you watch that drawing which is drawn by using surface modeling, you must understand what is exact appearance of that model. That is the importance of surface modeling. Then it provides the geometry for computer aided manufacturing and CNC machines. Obviously it is right. For computer aided manufacturing, you can feed the geometry in a software for part programming also. So it is useful for CAM. Please understand, and it is it is asked for multiple choice questions many times. So you remember this. It provides the surface geometry for computer aided manufacturing. Then next, it provides the geometry needed by the manufacturing engineer for mold and die design. This is also correct. For different process in manufacturing, you need to manufacture mold and dies. So their surface modeling is required. Remember this point. This is also for multiple choice question. Then it can be used to design and analysis complex free formed surfaces of ship hulls, aeroplane, then car bodies. So complicated curves that can be easily obtained in surface modeling. So this lacuna is removed and it is improved in surface modeling. Then surface properties such as a roughness, color and reflectivity can be signed and demonstrated. This is also advantage of surface modeling. So just I have discussed advantage of surface modeling. In the next lecture we will see types of solid model and use of solid model in nowadays. That is what about the wireframe modeling and surface modeling. So today we will see solid modeling. Actually it is a type of model in computer aided design. in computer aided design there are actually three types of model: wireframe model, surface model, and solid model. Right now we are going through solid modeling. Rest of these two types, wireframe model and surface model, you may see that videos on youtube.com. Now let us see a solid modeling. This is a bit from chapter number 2, geometric modeling. So in solid modeling, solid definition include vertices, that is also called as a nodes, then edges, then surfaces, then weight of the object and volume. So these are the four parameters considered in solid modeling. So solid model has surface, it has a weight, it has a volume, it has a edge, and it has a finally node. So this is a solid model, and its applications are nowadays more than expectation. Let us see the advantages and application of solid model and what is actual use of solid model. It has all the advantages of surface model, because surface model has a because it is a uniqueness, it is having uniqueness, then it is not difficult to understand. Solid models are more realistic, and they are also having surface profiles, plus it consists of volumetric information. So for example, if you have drawn assembly of different components in CATIA software in part modeling, so you can find out easily its volume, you can find out its center of gravity. So these things are easier to find in solid modeling. But in surface modeling, you can see a surface, it just represents a surface. It does not give the value of volume of that object. So this is not applicable to surface modeling. It allows designer to create multiple options for design. Obviously, editing of the solid model nowadays, it is very easy, and you can modify such solid models very easily, quick, fast. Therefore you can have different options. Suppose you are drawing a piston and cylinder assembly in a software, you can easily modify the design of piston, design of cylinder, and you can easily change the diameters of that cylinder, diameter of that piston, and you can match their dimensions. So these points are become easier in solid modeling. Then 2D drawings, assembly drawings, and exploded drawings are generated from the solid model. This is very good advantage. Suppose you draw an assembly of 1,000 components, you can generate their front view, side view, top view within a second. This is a good advantage. So you don't need to draw for a long time, and it is a lengthy procedure. But in case of solid models, in case of CATIA software, SolidWorks software, Solid Edge software, Unigraphics, ProE, you can generate these views, FV, SV, and TV, within a second. That is called as a drafting module in all the software. So this drafting module is available in all types of softwares, CAD softwares, and you can generate these models. Rather, you will experience it. On the same channel, we have the video of drafting. You can generate these views in a quickly and fast. You can see these videos in YouTube channel. It can easily be exported to different finite element method programs for analysis. See, different finite element method programs, it means a software of FEM, like ANSYS is a software. We have a lot of videos of ANSYS software on the same YouTube channel, you can see. many advanced tutorials we have uploaded on this ANSYS software. This is a finite element method program. Suppose you want to do the analysis of very critical shaped component. Take an example of piston and cylinder assembly. It is very difficult to analyze it, but you can draw that model in CATIA software or in Pro software. Save that model in IGES format, and you can import that IGS format file to the CATIA software, and you can reduce the time required for drawing the assembly, and easily critical components are imported to ANSYS software. Nowadays ANSYS software provides analysis of very critical shaped component. It imports all the components without losing the features. Please mark this line. It imports all the geometries without losing its properties. For example, sometimes what happen, if you import the model from CATIA software to the ANSYS software, their surface may be deleted, some edges may be deleted, some points of that model may be deleted. So this is the loss of data, and it happens in lot of CAD softwares. But in advanced versions of ANSYS software or any other FEM softwares, this lacuna is removed, and their programs, their software visibility features are improved. Let us see the next advantage. It can be used in newly manufacturing techniques. Computer integrated manufacturing, that is CIM, computer aided manufacturing, that is CAM, and design for manufacturability, DFM. In 3 out of these 3 applications, solid model is almost useful. You can draw a solid model and you can generate its part program also. This is a good advantage nowadays. You don't need to write a separate part program. Later on you can improve that part program, but these facilities are available. In CIM, computer integrated manufacturing system, obviously it is there. You can implement the CAD software. In CAM, computer aided manufacturing, obviously you can implement CAD softwares. And design for manufacturability, DFM, it also consists of use of CAD softwares. So CAD softwares are, their applications are unlimited. Apart from these 3 also you can implement CAD softwares. Then next point, volumetric and mass properties of object can easily obtained. Obviously, as I told you at the start itself, you can calculate the volume of critical shaped components in one click. Mass properties you can obtain. Also you can obtain center of gravity of that component. See, center of gravity plays very important role in the design of component. Suppose you have drawn a chassis of a car and you have to find the center of gravity. What is CG? Where whole mass of the body is supposed to be concentrated. So on that particular CG or particular point of that CG, you can apply a mass, you can apply a weight, and you can go for the further finite element analysis of that component. So CG is easily obtained in solid modeling. You take any model, that model may consist of 1000 components, 5000 components, no matter, no issue, no difficulty. It is very easy to obtain CG in solid modeling. In my experience, I will say finding out CG and using that CG in design analysis is very important task. But nowadays I don't find any students or any research, they do not focus on the center of gravity while doing the finite element analysis. So you must find first of all center of gravity, apply the load on that point of center of gravity, then you do the analysis, get the results and go for the proper conclusion of that analysis. That will be a realistic approach to the finite element analysis. Just remember this. Then disadvantage of solid modeling, obviously it is more intensive computation than wireframe and surface modeling. Computation, what does it mean? Because it requires obviously more space and you need more calculations in solid modeling. You require more space for saving the solid models as compared to wireframe and surface models, as it requires powerful computers. I remember one experience. Our students were drawing a solar vehicle model in CATIA softwares, and almost that file size was around 200 MB. Can you imagine this? 200 MB file size in CATIA software. It has taken almost 50. Okay, today we'll see the difference among wireframe model, surface model and solid model. So in the surface model, solid model and wireframe model, there are different applications that we have to analyze, and we have to choose a perfect application and perfect type of that particular model, so that we can go ahead by using different CAD softwares. So first of all, let us see on the which basis we are going to understand this difference among wireframe model, surface model and the solid model. So here in this case, computer memory space required for wireframe model is less. You can see on this slide. A wireframe model requires less space, but surface model it requires moderate space, and solid model it requires larger space to store the models in your computer. So entities used in wireframe model, which are these entities used? Point is used, line is used, circle is used, arc, ellipse, synthetic curve such as a Bezier curve or Hermite curve or B-spline curve. So these types of entities are specially used in wireframe modeling. Then if you take a case of surface model, in case of surface model, planes are used, then revolved surfaces are used, ruled surfaces are used, tabulated surfaces are used, and free form surfaces are used. So these type of surfaces we will learn separately, because these are required in different types of car body shapes modeling or sheet metal modeling. So these surfaces are also important in modeling, surface modeling. Now next is solid primitives such as a cone, cube, wedge surface, sphere. All these basic types of solid models you are knowing. Volume is there, cone is there, cube is there, then oval shaped components are there. So these are the basic solid model shapes, and these are used in modeling. Then input data required for wireframe model is more. Suppose you want to draw one model and you require coordinates of points, you require dimension of particular line, you require data related to circle drawing. So data required for modeling a wireframe model is more. It is moderate in surface modeling, and it is less in solid modeling, because in solid modeling you can just enter one or two dimension and you can generate the solid model of small cube also, circle also, or you can say a cylindrical model. So that is more simple in case of solid model. If you take an example of automatic orthographic perspective isometric view generation, so these types of graphics concepts which are more complicated to understand, these are impossible in case of wireframe model. In case of surface model also these are impossible, but in case of a solid model you can easily view isometric view, then automatic next parameter, that is NC code generation. So NC generation, it is not possible in case of wireframe model. NC code generation, it means that
writing a part program. So writing a part program, that codes are related to part program, this cannot be generated by using wireframe model. In case of surface model also it is automatically possible. Surface model helps us to generate or to write a part program by using different components. Similarly, solid model is also useful to generate components and to generate their correct. Then, if you take the next parameter, that is rendering shadow effect. In case of rendering shadow effect, it is not possible in wireframe modeling, but it is possible in surface model and it is also possible in solid modeling. So shadow effects you cannot give in wireframe model, no? Because wireframe model itself is a skeleton. It does not represent surface, so therefore it will not have any kind of shadow or rendering effect. Rendering effect, it means that you can give different colors, you can apply different types of materials on that CAD model. But it is possible in case of surface model, as you can see. On surface model, you can give different colors, you can apply different types of material on surface model. Also you can apply different types of materials on solid model itself, and there you can generate a shadow effect. If you consider a next parameter, that is cross sectioning. In case of wireframe model, cross sectioning is not possible. It is possible in case of surface model, it is not possible also in case of surface model, but it is possible in case of solid model. Now cross sectioning, it is not possible in case of wireframe model, it is straightforward, because wireframe model, it does not have sections. Surface model also, it does not have a section, because surface model, it is just representing outer surface. There is nothing inside that model. There is nothing inside that model, it just represents the external appearance of the object. So therefore surface model will not have any kind of section. But solid models, you can generate the sections automatically, and that features are available in CATIA software, POE software, Solid Edge software, SolidWorks software, Unigraphics software. These are commonly used CAD softwares, and there these facilities or features are available. Now we will see next parameter, that is CAD CAM CAE modules. So drafting is possible in case of wireframe modeling. In case of surface modeling, drafting and design both are possible. But in case of solid model, drafting, then design, manufacturing, analysis and assembly, these three things are possible. These three things are possible in case of a solid model. Drafting is easily possible. If you draw an assembly of 1000 components, you can generate their front view, side view, top view very easily. Also design is possible in case of solid modeling, and their analysis, finite element analysis is also possible in case of solid model. Then make different mechanisms you can simulate by using a solid model. But it is a good advantage of solid modeling. So nowadays solid models are used worldwide for any kind of operations. Even though I have seen some examples, solid models are also used for external representing external appearance of the object, rather to use surface model, because solid models are very easy and simple to draw. Right now, if you go to youtube.com, you search different types of models, you can search different tutorials, you can easily learn how to draw a solid model. You don't need to go for different types of courses for that. So solid models are that much simple. Then you can see the next parameter, calculating of physical properties such as volume, mass, then moment of inertia. So these physical properties are not possible to calculate by using wireframe model, but these are possible by using surface model. Surface model, it can calculate only area. It cannot calculate moment of inertia. But in case of a solid model, you can calculate all these properties: volume, mass, moment of inertia. Such physical properties you can calculate by using a solid model. Then next parameter, that is the elimination of hidden lines. So elimination of hidden line is not possible in case of wireframe modeling. Possible, but you have to do it manually. Automatically, hidden lines cannot be eliminated in case of wireframe modeling. It is possible, but manually you have to do that task, and obviously it is time consuming. Then in surface modeling, elimination of hidden lines may be possible, but that feature is provided in some softwares. In SolidWorks software, that feature is provided, and you can easily eliminate hidden lines in case of surface modeling. But in case of solid model, it is easily possible to eliminate hidden lines because it does not accept hidden lines itself. Solid models cannot be generated if you mention some hidden lines in modeling. So there itself elimination of hidden lines happens automatically. So you don't need to go for eliminating hidden lines separately. Automatically you can eliminate the hidden lines. That is a good advantage of solid model. Then if you go ahead, design parameters optimization. Obviously, it is not possible in case of wireframe model, it is not possible in case of surface model, but it is possible in case of solid model. So surface model, wireframe models why these are not suitable for parameters optimization? Because there is some problem. You cannot have a physical properties, so you cannot use these models for finite element analysis purpose. But you can use solid model for finite element analysis purpose, and you can go ahead for optimization purpose. Surface model you can take to the finite element software, means ANSYS software you can use for analyzing surface model, but you need to provide some thickness to that surface. Then these surface models can be used for finite element analysis purpose. Then next is that you can use this wireframe model you cannot use this wireframe model for detecting defects. Defects cannot be determined. Exact location of that defect cannot be determined in case of wireframe model. You can detect different defects by using surface model. Also, you can detect some defects by using solid models. In case of surface model, exact location of defect is very difficult to identify. So therefore, wireframe model is not suitable for detecting the defects. Surface model is suitable, solid model is suitable, but wireframe model is not suitable. Suppose there is some hair crack in the model, hair size crack is there in the model, and that can be only determined by using solid model. You can generate its front view, side view, top view in the solid model, and you can easily see the where crack is happening in the solid model. So exact location is very simple to identify in case of solid model. See, speciality of solid model is that you can generate front view, side view, top view, as I discussed during CAD/CAM CA modules. Solid models are used for finite element analysis purpose in case of CAD softwares also. You are under impression that only CA softwares are used for finite element analysis, but in case of CAD softwares like CATIA, like SolidWorks or Solid Edge, basic types of finite element analysis can be performed in that software. So solid models are used worldwide. Their drawback is that huge computation work is there. Processor has to work a lot. You need more RAM and large space is required to store the memory. To store different models. I remember almost 150 MB size of solar vehicle we had modeled year ago in a CATIA software, and it has taken almost 15 minutes to open in a software. So solid models requires large space. So this was about the difference among wireframe model, surface model and solid model.